C, a programming language that needs no introduction. If you're watching this video, you probably already know what C is and why it's so important. But for those who don't know, let me give you a quick overview. The C programming language was developed by computer scientist Dennis Ritchie at Bell Labs in 1972. It was created as an extension of the earlier language BCPL, which itself was based on another language called B, which was developed by Ken Thompson at Bell Labs. Fun fact, B was implemented on the PDP-7 minicomputer, which was so named because it had only 7 kilobytes of memory. The initial purpose of C was to write utilities for the Unix operating system. You see, as Unix grew, it became increasingly difficult to maintain and extend due to the use of a macro-based preprocessor and the inefficient assembly language used for the code. As a result, it was decided to develop a new language that combined the power and efficiency of low-level assembly language with the flexibility and ease of use of higher-level languages like Lisp. And that's exactly what C delivered. In fact, by 1973, the entire Unix operating system from user utilities to the kernel was virtually rewritten in C. C was also instrumental in the development of other important systems, like the VMS operating system from Digital Equipment Corporation and the QNX real-time operating system from Quantum Software. But why did C become so popular? What makes it special? To understand that, let's look at the state of software development back in the early 1970s. Prior to C, most languages were either too difficult for practical use or too easy, resulting in code that was either too expensive or too slow to build. For example, languages like Fortran and COBOL were quite cumbersome to use and led to bloated programs with unnecessary overhead. On the other hand, languages like Lisp were perhaps too easy and fast to use. But they were too inefficient and too esoteric for large-scale commercial applications. C offered a nice balance between these extremes, providing enough abstractions to make programming easier while maintaining low-level control over hardware resources like memory. Let's consider some of the things that made C stand out. First, C has a clean syntax that is both powerful and easy to read. The language has a relatively small set of keywords and operators, making it less cluttered than many other languages. Second, C supports data typing, meaning that variables must be declared with a specific type before they can be used. This helps to catch errors early on during compilation rather than runtime. Third, C provides constructs for structured programming, which is a disciplined approach to writing programs that makes them easier to understand and maintain. For example, C supports the use of blocks, scopes, and control flow statements like if-else and while loops to create well-organized programs. Finally, C is a compiled language, which means that source code must be translated into machine code before it can be executed. This results in programs that are both efficient and fast-running. These features made C suitable for a wide range of applications, including system programming, device drivers, embedded systems, and game development. In fact, C has been used to develop everything from small microcontrollers to large server applications. As the language evolved, different dialects and extensions emerged, leading to confusion and inconsistency across implementations. To address this, standardization efforts began in the 1980s. Initially, the American National Standards Institute, or NSI, published the AN18 89C, 1989. This standard, often referred to as C89, defined the language syntax and behavior, as well as the standard library of functions. It also introduced several new keywords and features, including the const and volatile keywords, as well as the inline function specifier. However, as the language continued to evolve, it became clear that the ANSI standard was not sufficient. In 1990, the International Organization for Standardization, or ISO, took over the standardization effort and published the first ISO C standard, C90. In 1990, this standard added several new features, including the introduction of the long integer type, as well as the underscore bool type for Boolean values. It also introduced the restrict and underscore no-return keywords, as well as the complex and imaginary data types for working with complex numbers. Additionally, C90 introduced the Standard Template Library, or STL, which provided a rich set of data structures and algorithms for use in C programs. This greatly enhanced the language's capabilities and made it more suitable for a wider range of applications. However, the evolution of C didn't stop there. In 1999, ISO published the C99 standard, which introduced even more features. One significant addition was the inline assembly language feature, which allowed programmers to insert assembly language code directly into their C programs. This was useful for situations where a C programmer needed to access low-level hardware features that were not exposed through the language's existing API. Another important feature introduced in C99 was the variable length array, or VLA, which allowed an array's size to be determined at runtime rather than compile time. This provided more flexibility when working with dynamic datasets. Additionally, C99 introduced several new library functions, including the sendPrint function for formatted output and the nanosleep function for high-resolution timer-based applications. These enhancements further expanded the language's capabilities and made it more versatile for developers. In 2011, ISO published the C11 standard, which introduced several new features aimed at improving the language's performance and conciseness. One major addition was the ability to specify the alignment of structures and unions, which could improve cache performance in multi-core environments. Additionally, C11 introduced the _generic and _aligned keywords, which provided more control over how generic types and structures were allocated in memory. The standard also introduced several new library functions, including the isalnum and isgrep functions for character handling, and the memkey_s and memov_s functions for safer memory copying. These updates reflected the ongoing evolution of the language and its continued relevance in modern software development. More recently, in 2018, ISO published the C18 standard, which introduced several new features focused on improving the language's efficiency and safety. One notable addition was the optional bounds checking feature, which provided a way to specify whether an array's bounds should be checked at runtime. This allowed developers to choose between the safety of bounds checking and the performance of unchecked access for situations where an out-of-bounds array access would not cause an error. C18 also introduced a new integer type, int_fast8, which guaranteed a minimum execution speed for operations on 8-bit integers. Additionally, the standard added several new library functions, including the command_s and rename_s functions for file system operations, and the UTF-8 and WCTO_s functions for wide character handling. These new features demonstrated the ongoing efforts to enhance the language's efficiency and safety, while also expanding its capabilities for modern applications. And just last year in 2024, ISO published the latest C23 standard. Among its many new features, C23 introduces 3 new integer types: int_least8, int_least16, and int_least32. These types guarantee a minimum number of bits for integer types, providing more flexibility for developers when choosing appropriate data types for integer variables. The standard also enhances Unicode support by introducing 2 new functions, alto and tolauer. These functions allow for easier manipulation of wide character strings, enabling more robust support for multilingual applications. Additionally, C23 improves the language's memory handling capabilities with the introduction of the aligned_alloc and aligned_free functions. These functions provide more control over memory allocation and deallocation, allowing for better alignment of memory blocks for improved performance in certain scenarios. Overall, the C23 standard reflects the continued evolution of the language and its ongoing relevance in modern software development. Today, C remains one of the most widely used programming languages in the world. Its efficiency, portability, and close relationship to Unix and its derivatives have made it an essential tool for developers. Although it's not as popular for general-purpose programming as languages like Python or Java, C continues to be widely used in areas where performance and control are critical. For example, it's commonly used in embedded systems, game development, and high-performance computing. Additionally, C is still widely used in the development of operating systems and device drivers due to its efficiency and low-level access to system resources. Whether you love it or hate it, C is undoubtedly one of the most influential programming languages of all time. Its impact on the development of software and systems is immeasurable, and it will continue to be relevant for years to come. Thank you for watching, and I'll see you in the next video.